All right, here we go. Now we're going to talk about decay. This is section 4.5. Decay, you have the same formula. Y equals b to the x. The parameters on b, your base, are different. We just got done saying growth is greater than 1. What do you think decay is?
Negative. Less than 1.
Less than 1, but what? But greater than 0, right? It has to be less than 1, but it's also greater than 0. Notice it doesn't equal 0 or 1. If it equals 0 or 1, it's not exponential anymore. Okay? So it's some number in between 0 and 1. What would examples be?
1/2.
Y equals 1/2 raised to the x power. Y equals negative 3 over 2 raised to the x power. Those are both examples. No. What I do wrong here? Somebody said 3 over 2 and I just wrote it down. What
It's over 1.
What would this one be?
1.5.
What should I make the 2?
3 over 4.
3 over 4. Now we got decay. I'm sorry. Now we got decay. Both of these are decay. Is that hard? No, it's not hard. Just a little bit of study. So now let's talk about the graphs of these. What are the graphs of decay going to look like? They're not going to look like J's and 7's. What are they going to look like? Are they getting closer to the x-axis or further away from the x-axis? Closer. They're getting closer too, right? We're way up here, and we're coming down, we're coming down, we're coming down, and then it's right there. What letter does that look like?
L.
An L. Very good. If I flip this around the x-axis and put it in the bottom, what would it look like? Lowercase what?
R.
Lowercase r. Exactly. The key thing to remember with decay, and you want to write this down, is that it's getting closer to the x-axis. Closer to the x-axis. Questions? Any questions about decay? Two types of questions. First type question is going to say, is it growth or is it decay? Piece of cake. The second type question is going to be, pick a graph from one of these 4 choices. And you have to be able to do that. You graph these exactly the same. Let's graph them. Y equals 4 over 5 raised to the x plus 2. First question, growth or decay?
Decay.
It's decay because 4/5 is less than 1 but greater than 0. Is it going to look like an L or an R? Well, I should write R like this. R. Does it look like an L or an R?
L.
It looks like an L because that's positive. It looks like this. Okay, so you're on the right track. Now we got to pick a number, a value to plug in for x so that we can get one value. What value do you think would be a good value?
0.
0 makes all of this become 1.
3.
1 plus 2 is 3. So we look at our graphs, A, B, C, D, and we try to find out one that goes through. What if 2 of them are decay, they look like L's, and they both go through 0, 3? What might you have to do? You'd have to pick another number, but that's going to be ugly, right? I would pick 1, right? But you're going to get a fraction because when you stick a 1 right there, you just get 4/5. It would be 2 and 4/5, right? It gets ugly. That's why 0 is the best value to plug in. And 99 times out of 100, all you got to do is pick 1 point and you can figure it out. They don't make them that close together. Okay? Any questions? All right, get your workbook out. Turn to page 134, and let's do 1 through 6, I think. 134, page 134 in your workbook, and let's do 1 through 6.